Okay, today we're going to look at quadratic application problems. Okay, that basically just means we're going to look at word problems that have to do with quadratics that are all going to end up, if we graph these different word problems, they're all going to end up looking like a parabola. Remember, a parabola either looks like an N or it looks like a U. Okay, also remember that quadratics, that means that the parent function is y equals x squared. Now we're going to see some different letters since we are talking about applications, but that's the format that these equations are going to be in. Okay, we're actually going to skip this first slide, okay, just because it's pretty self-explanatory, it's pretty easy to figure out what those answers are. And we're going to go to this slide. Okay, so these are the two different quadratic functions that we're mainly going to look at today. The first one has to do with height. So height is equal to, the height at t time is equal to negative 16t squared plus 128t. Okay, and in this situation, the h represents the height. Okay, and the t represents the time. Okay, now with this, with the height, okay, because the height is depending on the time, the height is going to be along the y-axis. It's asking us what axis it's going to be along. Okay, and why? It's because the height depends on the time. Okay, so time here ends up being independent because we can't stop time. Okay, which means time is along the x-axis. Okay, what you need to know is that when an object hits the ground, what height is it at? The height is going to be at 0. Okay, you're going to have to keep that in mind for some of the problems that we're going to see. All right, so let's look at this first problem. It says the path of the rocket is given by the equation h of t equals negative 16t squared plus 128t, where h is the height and t is the time. It says using your calculator, answer the following questions. So we're going to be using what we've learned about the calculator the past few days, and you're going to use that to answer these questions. Okay, so the first question is, how long is the rocket in the air? Okay, now I know that this rocket, this is going to be important to know here in a second, that this rocket obviously is going up and then it's coming down. Okay, so in this case, we're going to have a maximum. All right, so I'm going to go ahead and I'm going to go to my y equals, so y equals, and I'm going to type this in. So we have negative 16t squared plus 128t. In this case, an x is going to come up, and that's okay. All right, we're going to hit graph. Now keep in mind, we know that this is going up and then coming back down. So even though we cannot see the left side, okay, we know that it is starting at 0. Starting at 0 height, it's starting at 0 time. So I cannot see the part that is on the y-axis. This piece right here, I can't see it, but it's on there. But you can see the side that's coming down. Okay, this one's just a little confusing because you can't see the whole thing. All right, but let's look at that first question. It says, how long is the rocket in the air? Well, to know how long the rocket is in the air, I need to know what time it hits the ground. Okay, so it starts on the ground, it goes up, and then it comes down back at height 0. Okay, so what I need to know is when my height is at 0, and we know how to calculate the zeros. We did that the other day. Okay, so what I'm going to do is hit second, trace, and I want the 0, so number 2. Okay, my cursor right now is at 0, 0. I need to get it onto where I can see it on the other side. Okay, and I should be starting to see it pretty soon. being good past it. Okay, if I just look at the little tick marks on the x-axis, I can see that it's going through about 8. So even though I can't see my cursor, I'm going to go ahead and put it at about, I don't know, maybe at 6 point something, or anything less than 8, because I know that's going to be to the left, even though I can't see it. This is kind of a special case. We would have to zoom out more, and then it just gets the graph gets kind of funky. So let's just do it this way. So I know that's to the left, and then I know, so you can see the arrow that popped up on the graph. If that looks like to be about 8, I know that anything more than 8 is on the right. Okay, so go to any number you want that looks like it's more than 8, and press enter. Then press enter one more time, and you can see that our 0 is at 8. Okay, that means that's where the rocket hits the ground at 8 seconds. Okay, so how long is the rocket in the air? For 8 seconds. Okay, what is the maximum height the rocket reached? Okay, we talked about maximums last time. Okay, so we need to calculate this. Okay, so I need to go back to my calculator. Okay, and I know that my maximum, even though I cannot see it, is in between my 0 and 8, because 8 is where it hits the ground. Okay, so I'm going to go second trace. Remember, we want number 4 for maximum. Okay, right now my cursor is at 8, negative 11, so I'm going to need to go to the left. Okay, at least at 0, because that's where I know for sure it's on the left side. Okay, I think my cursor just came down. There's mine. Oh, I hit it too many times. Okay, so you should be able to see it. Okay, as long as it's on the left of where you think your vertex is, you can just press enter. Okay, and then it needs to come back around. You can probably see yours better than mine. My calculator has a little bit of a lag. Okay, and I know that the right side is definitely going to be at 8 or more, because that's where it came down and hit the ground. So I can just assume that's on the right side and press enter. And press enter one more time. And there's our maximum. So our maximum was at 4,256. And this question is asking me what is the maximum height. Okay, and we know our height is only going to be on the y-axis, which means that's my y value of 256. Okay, about how high is the rocket after 1 second? Okay, now second is my time, which in this situation, you know, it's our x value. Okay, so what I can actually do is I can go to my table and hit second graph, and I can go to 1, and I can see what my height is. So at 1 second, my height is 112. Okay, I can do the same thing for after 2 seconds. In my table, I can see at 2 seconds, my height is 192. Okay, it's asking after 2 seconds, is the rocket going up or is it going down? Okay, and here's how I know. We found out that the maximum was at 4,256. That means it's going up until it gets to 4 seconds, and then it starts coming back down. Okay, so I know at 2 seconds it is still going up. Okay, after 6 seconds, about how high is the rocket, I can find that still in my table. And at 6 seconds, it's at 192 again. But at this time, since it's after our maximum, this time the rocket is going down. Okay, do you think the rocket is traveling faster from 0 to 1 seconds or 3 to 4 seconds? And explain your answer. Okay, so we can look at the table for that also. So from 0 to 1 seconds, it went 112. It went from 0 to 112. So it went 112 here. Okay, from 3 to 4 seconds, it went 16. So I'm looking at this and I say, it looks like from 0 to 1, it's traveling faster because it went 112, whatever we're talking about, feet or meters. Okay, and here, and then from 3 to 4 seconds, it only went 16. Okay, now G says, what is h of 2 asking? Okay, we've seen this before, that if I compare h of 2 to h of t, that the function at the top tells us, you can see that the 2 replaced the t. So that's saying find the height when t is equal to 2. And we actually already found that on part D. And so at 2 seconds, the rocket was at 192. Okay, not every problem will be this complicated with this many questions. This is probably the most questions that you would be asked on one application problem. All right, let's look at number 2. A ball is thrown into the air. The path of the ball is represented by the equation h of t equals negative t squared plus 8t. Graph the equation over the interval. We're actually not going to do that, okay? But we are going to answer these questions. So what is the maximum height of the ball? All right, we know how to find the max. That's the easy part. So I'm going to go back to my calculator, go to y equals, okay, and I'm going to type in negative t squared plus 8t and graph it. We'll see if this graph looks any nicer than our other one. And it does. Okay, this looks a little more normal here. And I need to find the maximum. Okay, so I'm going to hit second trace. Alright, I want number 4 because it's my maximum. Right now my cursor is at 0, 0, probably where yours is too. Alright, I'm already on the left side, so I can press enter. And then I need to get it to the right side. Now here you should be able to see it come around to the right. Right, I can see my cursor now. So as soon as I get it over there, I press enter. And enter one more time until it says what your maximum is. Now 3.9999978, that's going to round obviously up to 4. Okay, yours may be different. Yours may have come out to be exactly 416. That's fine. We both end up with the same answer. Okay, so my maximum is 416. So let's see what the question's asking. What is the maximum height? Okay, now here our height is on the y-axis. Remember our time is on the x-axis. Okay, and my y value of my maximum is 16. Okay, what part of the vertex do we look at to find this? Okay, and I just told you that we're going to look at the y value. Now, when is the ball at its maximum height? Okay, again, this is talking about the maximum, which we have already found. Okay, we said that the height was the y value. Okay, that means that the x value of the vertex is going to be our time. Okay, which is 4. So what part of the vertex do we look at to find this? We look at the x value. Okay, because this is asking for when, not the actual height. Okay, how long is the ball above 7 meters? Okay, now what I'm going to do is exactly what we did on the last question. I can find this in my table. So if I hit second graph, okay, I can see here, at 1 second it is at 7 meters. So from 1 second all the way until 7 seconds, it is going above 7. So from 1 to 7, that would be 6 seconds. Okay, so up until now, we have been able to find every single answer that we needed from the calculator. You just have to know where to find it. A lot of these answers you can find from the table. Okay, the next one. We'll do this one and one more. A rock is thrown from the top of a tall building. the distance in feet between the rock and the ground, t seconds after it is thrown, is given by d of t equals negative 16 t squared minus 4t plus 382. Okay, now this number down here, that is our y-intercept. Okay, we saw this last time a little bit because some of you were asking me on the homework, why can't I see the graph? Okay, that's because of the y-intercept. And our graph is going from negative 10 to 10. If I were to pull up the window, it's going from negative 10 on the x-axis, and it's going by ones, and negative 10 to 10 on the y-axis and going by ones. Okay, so I know for sure right here, if I wanted to see this graph, my y-axis would need to go at least up until 382 so I could see it. Okay, so that's a good tell right there of what our graph is going to look like. Okay, also remember what the y-intercept tells you. That tells you where you begin. Okay, and this is talking about a rock being thrown from the top of a building. That means that's where the rock began, which means 382 is the height of the building. Okay, it doesn't really ask you that here, but it still is good to know that that's what that y-intercept is telling you. All right, let's look at the questions they asked. So it says, if I asked you to determine d of t equals 370, what would that be asking? Okay, now that whole thing right here, d of t, that means that's the distance. That's the distance at t time. So if it's asking you to determine d of t equals 370, it's telling you that the distance is 370, and then it wants you to find the time that it is at 370. Okay, if there was a number inside of the parentheses here for t, that would be telling you that's the time. But in this case, d of t, this whole thing, that means the distance is at 370. Okay, so it wants us to find that. It wants us to find when it is at 370. Okay, so I think that I can find that in my table, but I need to type it in my y equals first. So I type in negative 16 x squared minus 4t plus 382. Okay, and I just want to make sure I got my negative in there because mine kind of moved over. Okay, and it is. All right, so I'm going to hit graph just to see what this looks like, to see if I can even see it. Okay, so I can see that it looks like at negative 5 it's going up, and then it's coming down a little before 5. But that's not even what I'm looking for here. I want to know when my distance is at 370. Okay, so when I throw this rock, at what point is it at 370? So I can find that from my table. Okay, so if we look at this, I see at 0 seconds I started at 382. Remember, we said that that was our y-intercept. So I haven't thrown the rock anywhere yet. It is starting at a height of 382. Okay? Now at 1 second, it's at 362. Okay? Which means I've already passed up the 370 height, the distance. Okay? So it's somewhere in between 0 and 1. So I'm going to show you another trick in your calculator, and we've looked at this before, but a little bit different than this. So what you can do is you can hit second window, because we want to go to the table set. Okay, now our table start, that can start at 0, but we need to change what the table goes by, what the scale of the table is. Okay, so I'm just going to take a guess here, and I'm going to make my table go by quarters. So I want my time to go by 0.25. Okay, so let's pull up the table again. And let's see if now we can find out when it is at 370. And you can see at 0.75, it was at 370 for the distance. Okay, so solve when d of t equals 370, that's going to be 0.75. So how you could write this, which I wouldn't really expect you to write it this way, but you could, d at 0.75 times was equal to 370. So you could write it out that way. Okay, let's do one more, and then we'll be done. Okay, a ball tossed in the air from the ground level reaches a height of h feet, given by the equation h of t equals 144t minus 16t squared. Okay, what is determine h of 3 asking? Okay, so you can see if I compare h of 3 to h of t, the 3 has replaced the t. So that's telling you that the time is 3. Okay? It doesn't tell us what time we're talking about here. So it doesn't really matter, okay? But the time is 3. All right? So B is asking us, what is the maximum height the ball will reach? Okay, so I'm going to go back to my calculator. Let's go ahead and change our table back. That way it's not by quarters. So I'm going to go back to second window, and I'm going to change my table back to going by ones. Okay, so your table setup needs to look like this. All right, so I'm going to go back to my y equals now that that's changed, and I'm going to type this new equation in. So I have 144x minus 16x squared. All right, I'm going to hit graph because I need to find the maximum. Okay, so again, you can't see the left side of this parabola, but you know it's there because you're starting at 0 on the y-axis. Okay, you're starting at the ground, so you're starting at 0, the ball's going up, and then the ball's coming down. Okay, so I need to find the maximum, so I'm going to do second trace. Now I want number 4 for the maximum. Now right now you can see my cursor is at 0, 0. I know that's on the left side of my maximum. So I can just press enter right here because I know it's on the left. Now I can see that where my parabola is going through the x-axis, that looks to be about 9. Okay? Which I don't really care where it crosses the x-axis, but I do know that the closer to 9 that I get, the more it is on the right of the maximum, which is what we're trying to get to. So I'm going to use my cursor, and I'm going to just get it close to 9, so I know for sure that it is on the right of my vertex. Just something around 8 or 9 is fine. Okay, and then I'm going to press enter because I know it's on the right side. And enter one more time. And there's our maximum. So our max is at 4.5, 324. Let's see what this question's actually asking us. So it says, what is the maximum height the ball will reach, okay? And we know that t is our x and h is our y, okay? So if it's asking for the maximum height, I want to look at the y value, which is 324. Okay? Now c is asking us, determine h of t equals t24, or 224. So this is telling us our height is 224. It's wanting us to find the time that it is at 224. Okay, I believe this one comes out to be a little nicer. We don't have to change our table. So I'm going to go to second table to find this. And I want to find out when it is at 224 feet. So I can see at 2 seconds, it is at 224 feet. And at, let's see, let's keep scrolling because it's going up and then it's coming down. At 7 seconds, I can see it's also at 224 feet. So you can't forget to get both sides of that parabola. Now D says, after how many seconds will the ball hit the ground before rebound? Okay? So you have to know, this is one of the important things that you have to know. If it hits the ground, you know that your height is 0. Okay, so what we need to do is we need to find in our table when the height is 0. Now we know it's at 0 at time 0. Okay, but the ball is going up. You can see that in the table, and then it's coming down. So I need to keep scrolling until I see a height of 0, and you can see it there with 9. So the ball went up, it came down, and in 9 seconds, it hit the ground. Okay, so with your homework, you're going to have a bunch of types of these problems, okay? And remember, because I think it mentions this in the homework, that, and we're not going to do this slide, sorry, okay, but that independent, okay, that's X. Dependent is Y, okay? If we're talking about height and time, time is independent, height is dependent. If we're talking about distance, time is still independent and distance is dependent. Okay, so that might be something else that you see as you're going through this homework. We will have time to go over this homework next time, and I will be here. So if you have any questions on any of them, just save them for when we go over them in class. Okay?